Hello everyone. In this video, we are going to introduce live scripts. Some of you might have already used them, but if you are not familiar with this topic, please follow the rest of the video. And you might say, well, what is a live script? Because it is a script at the end of the day, but first thing is you can distinguish a live script from a script by the appearance of it. The appearance is a little bit different from a regular script, right? A regular script is just like this guy here, right? It has the MATLAB symbol with no picture, nothing, just code, while a live script has like the thumbnail of a picture and something. The extension is .mlx instead of .m. And you can create those when you go to MATLAB. Instead of new, you can say new live script, or you can create it here. And when you do that, this live script allows you to not only write the code, but it gives you a bunch of other advantages. Like what? Like, for example, once you run some code on the right-hand side on this window, you can immediately see the result. So if you want to do some plot or show some data, you don't need to do it in the command window. It's basically the second window here on the right side, which you can also bring it and make it in line with the text. That is your basically simulation window. That's the same as your command window here. So you can see the result right next to your code. And it's way more than that. Like if you want to insert some text, right? If you are writing a report, if you are writing a paper, a journal, whatever, although MATLAB is typically not your best bet in the first place, but it can be. Why? Because once you make whatever that you are writing, you can now export it. Not only you can export it to PDF or Word or HTML, you can also export it to LaTeX. Right? So if you're writing a paper in LaTeX, then you can directly export it to LaTeX, and guess what? Now you can do some modifications and it's ready to go as a paper. And it has the text tools that you typically have in Microsoft Word, not all of them, but a bunch of them, right? So you can insert the text, you can make it bold font, italic, underline, so on, do left justified, right, and just align the center, add bullets, and so on and so forth. So let's say here I want to write something, so I click here and say this is first test, right? And then, as I said, you can do all sorts of controls on it, right? And you can align, you can do whatever you need for a regular text, you can do different types of formatting. And better than that, you can insert equations. If you go to the tab of insert, not only you can insert text, you can insert now what? Equations, or even LaTeX equations, correct? So now if I want to say, let's say, for example, sigma xx, right? And it has also the Greek letters too, so I can say sigma and then underscore xx. And then this guy is equal to, for example, E, the Young modulus, times epsilon underscore xx, right? If it's like a 1D stress strain problem. So you can insert your formulas, you can insert pictures, right? So if you have a picture here from a basically stress strain plot or something, you can click here and then add your picture. Right here, I have a picture of the Hooke's experiment, so you can bring it. You can resize it, you can move it around by basically using the space tab. You can, if there is something here, you can go ahead and select it and then insert a hyperlink for it to refer it to some web or something. You can insert tables and so many other things that are very useful. You can even insert a task. Right, so let's say if you want to do some plotting, you can insert a task of creating a plot. I'm going to show you in a minute. And you can also add controls to make it a little bit more similar to applications, basically. So here I have this simple live code that I have written, live script. And this is, let's say, for the Hooke's experiment simulation. So you know the equation for the Hooke's experiment is the linear spring. So the force of the spring is equal to the constant of the spring multiplied by the deflection. And this is the Hooke's experiment, right? You add to the weights, you measure the static force, which is equal to the total weight, and plot it versus the amount of deflection of the spring, which is the current length minus the original length. And if you do that, and let's say here, you collect a bunch of data points, then this data point might look something like these circles. Of course, they are not going to be perfectly on a line because you have so much of randomness in your experiment, which comes from inaccurate measurements. It comes from the nonlinearity in the spring. It comes from maybe the spring still has some small vibrations that you neglected. Comes from deflection of the members and so many other things. Your measurement is not exactly parallel to the spring and so many other things that can make this relation not be perfectly linear like this. So what I did here is I'm trying to simulate that behavior, and let's say here I have masses of 1 to 10 kilograms, and then the weights are of course g times x. I assume that the original spring constant for the spring I'm trying to measure is 120 Newton per meters. Here, if you see, I'm trying to create the values for deflections, and I say deflection is those forces, the spring force, which is equal to the weight, divided by the constant plus some randomness, right? So here I'm not making it perfect relation, I'm adding some randomness. And this randomness is basically some random numbers, which could be from the rand function, which is a uniform distribution, or rand n, which the data are being pulled out from a normal distribution. So I'm taking the data out of one of those distributions, depending on what you select here, and then multiplied by a scale, right? The larger the scale, the more you see the points are deviated from the line. And that amount of scaling, also, I ask you to basically choose from this slider here, right? So I allow you to choose the type of randomness and the scale of the randomness, and every time you change the scale or you change the type of the randomness, this plot that I have, which is the force, which in this case is the weight, and the delta y, the plot of the force versus delta y, does change. That's why we can call it a live script, because you see the immediate result of changing any part of your code in the plot on the right hand side. And I do not need to switch between the editor and the command window, because the command window is already here on my right side. So I'm doing the plot, and then I'm using a curve fitting command for the data using a simple line. So you see I'm using an order of 1, which is for a line. I get that. I show the slope of the line, which is the spring constant here for you. As you can see, it's not going to be estimated to be a perfect 120, right? It's estimated to be 105 because, of course, I have all of those random measurements. And I'm also going to plot the fitted line, which is in red, versus original data, right? So this is a simple Hooke's experiment. As you can see, I have added text here. I have added a formula here. I brought the picture here. If you have linked to this data to some website, you can just add a hyperlink, right? And everything is just working fine. The things that I wanted to show you is, one, how do I add, let's say, a drop-down menu like this, or a slider like this, and use it in my code. So I'm going to show you that. But as I said, everything else is pretty clear. So how did I do that? So if I want, let's say, to create some control for a parameter and let that parameter change by the slider instead of me directly typing the number, let's say here, for example, I have x equal 1 to 10, and then I have a parameter k, and this k, instead of me typing a number, say k equals to, and instead of typing a number again, I come here under the live editor, go to control, and then say, hey, this k is coming from the slider. And it says fine. What do you want to label it? I say K. What range does it change? Let's say it changes from 2 to 5, right? And you want this to change in what steps? So when you click on this slider, how much do you want it to change as you drag it left and right? Do you want it to change small amounts or large amounts? How big the jumps are going to be? Let's say 0.01. I want fine changes. And do you want to run it when the value is changing? You say yes. You don't. Basically that makes the effect of changing K immediately. Okay. So as you're changing K, you see your plot on the right hand side does change. So that's it. So you see here, I here created a slider, and now my K, instead of being assigned as a number, it is directly read from what? This slider. So now K is going to be what? 3.63. Then I say Y equals K times X, and then I say what? Plot X and Y, and let's say those circles, correct? So if I run it here, you see the result is first showing here on my right hand side. And now all I need to do is to change my K, and you see immediately the plot does change, right? Now you might not see an amazing change here, because what it does is really changing the range of the X and Y. But if you fix the range of X and Y, so you use the command access and fix it, let's say just I want it to go from 1 to 10, and then maybe from 0 to 20. Okay, now you can see the effect better, and let me run it again. So now you clearly see when I change the slope, you clearly see that, right, the effect is much more visible. Okay, so this is the live script. And now let me show you a couple of other things. So not only you can have this plot to be on the right side of your code, you can bring it and make it in line with the code. So if you click on this guy, now you see, instead of being on a separate window, now it is in line with the code. So now when you change it, this guy is going to change here in the same place as the rest of the code. Or another thing you can do is this guy, which is hiding the code. So if you do that, then the only thing you will see is really those controls that are left. Any other part of the code that you manually entered is going to be hidden from the user, right? So now it looks kind of like an app again. By the way, the figure itself, when you move your cursor over it, you still get the controls of zoom in, zoom out, pan, and the data tip, right? And let's say here you forgot to add X label, Y label, or something. Well, one way is to go back to the code and add it. The other way is if I just click on this figure, it adds a second tab for me here, a fourth tab for me here called figure. So you see that figure tab is not here normally, but once I click here, it is added. And now guess what? If I click on X label and say X, I can do that, and then it asks me, hey, do you want me to update the code? Basically add that extra line to the code. You say yes, and then it does it for you, right? Or let's say I want to add the grid lines. So I just click on grid, right? And then it does that for me, correct? So whatever that you need, you can do that. Let's say here I want, for example, to add a Y label also, and I want the Y label to be Y, right? So it is showing the code, anything, right? Whether you want to update it or not. And you can add all sorts of other properties of the picture. You can add annotations, right? So I want to add an annotation here, right? Like that. And I want to be able to modify anything, so I can do that. And then it is allowing you to basically, if you want, change anything. So this is about this parts of the plot. As I said, you can do a task. So instead of doing this, you can do this with a task too. So let's say here, I just generate this data, and instead of me separately typing the command plot, I can do that plot using a task. Say, hey, the task I want to do is to create a plot. And many other things that you have available in MATLAB, you can bring them and basically create a task for them. So here I want to have a task of creating a plot, and then it tries to generate the code for me, allows me to select the variables of the workspace, let's say in this case X and Y, and then it generates the code. So let's say I want to create this plot, right? And then it says, what do you want now? What are your X data, Y data? So I say my X data is X, my Y data is Y, and then it allows you for further selections, right? So what is it that you want? Do you want to select your marker style, right? Do you want to select your line style? So it allows you to select anything that you want, correct? The basic things, right? And that's it, correct? So it does do this task for me, and now I can do what? Can create the plot here, along with everything else. So now if I hide my code, again, you see that task is gone. So you're not going to see any task. Good? So that's what I'm trying to tell you, that this live script is basically making life a little bit easier, although it is kind of dumbing down MATLAB users of just using everything like an app and not writing a code. But it is making life for some people a lot easier. And the same thing you can do with the drop-down menu, right? So you create a variable and then say this variable type is coming from what? It's coming from a drop-down menu. Then say, okay, give it one name, and then what labels do you want? So you can say option 1, right? And then option 2. And give them values, and then here if you want to add further, but other than that, that's it. And you can even add a semicolon here. So now you can go ahead and select it, and then here you come and make a decision. If the type is option 1, do something. If it's type option 2, do something else, right? So all of these controls that you have here, edit field, checkbox, button, and so on, right? You can add a button here. Say, hey, for example, only if I push the button, then do the plot for me, right? So these are all of the things, the controls that you have. And as I told you, you can find them under Insert, you can find them under Live Editor, and you can change the view. And when you're all good, then you can go ahead and export them, let's say to what? To a PDF, and you can see the result of that PDF that I'm going to show you in a second. So this is the export in PDF. You clearly see everything I added is here, right? So you can use that for your lab report or something, right? Or as I said, you can export it to LaTeX and save it, and then you can use this, although it's not like really pro, but it can help you at least generate some parts of LaTeX code for your paper, right? And the final thing, I just told you that you can add a button and use that to run your code, right? So you go here to control and add a button, and this button you can give it any label that you want. You can call it run, whatever, right? You don't want it, you can say plot, correct? And then you can say run some current section, run all sections, right, from current section to end, and so on. So you can divide your code into sections if you want, and run only some part of it, all of it, and so on, right? And so now if you look, when I click on this guy, it is going to generate new data, and it is going to get you some new plots and something, correct? So this is the effect of this button plot that will generate new data for you. So hopefully this video was useful to you and you learn how to use a live script. to write your reports, to help you write your papers and so on. So I will see you in next video. Thank you.